In this section of 1.2, we're going to use similar triangles to find the length of the missing side. So these two similar triangles have the orientation the same way, so we can use that to match up our corresponding parts. So let's see, start with triangle ABC. We'll set that as our numerators when we set up our proportions. And I can see that A is going to correspond to D, B will correspond to E, and C corresponds to F. We're going to do number 53 this time. And in 53, let's see, we have B, E, F, and C. So that's this piece of the proportion. We don't really need that A and D. So the B, that's the 6. I'll put a 6 for B. And let's do, for E is the 18. And C, that's our variable that we need to solve for. And F is the 33. So that is my proportion, plugging in the information we know. Now to solve for C, I need to cross multiply. And I'm looking at this, there's some pretty big numbers. So cross multiply, I think first multiply the 6 by 33, and then I'd have to divide by 18. It's some pretty big numbers. And I could do that. I could go out to the side and multiply by 6 and get 198. But first, before I jump to those big numbers, I'd want to ask myself, is there an easier way? Can I make these numbers smaller so they're easier to work with? And 6 over 18 has a common factor of 3, or 6 actually. So I can reduce these each by a factor of 6, and I get 1/3. So that's a much prettier, smaller number to deal with. So now my new proportion is 1/3 equals C over 33. That's easier numbers to work with. So now when I cross multiply, I get 33 times 1 equals 3 times C. Then to isolate the C, divide both sides by 3, and I get C equals 11. So there's one of my answers. Oh, actually that's it. I have the other 3 already. So for number 53, I was just looking for C, and that gives me my final answer.